Okay, this is lesson 9B, part 2. 9A, part 2. Sorry, 9A, part 2. We're in the second part of 9A. Okay, so when the conditions are met, and again, the mu is the middle of this guy, the mean is the slope here. It's kind of a weird interval we're going to be doing. Most of the time, we don't know the standard deviation. So they're just saying you can eventually get to this formula. This is that formula is the one you need to write down in your notes. So we need that. It is on your formula sheet. You don't have to memorize it. But that's how we find what's called our standard error. We don't use standard deviation because we don't know the population standard deviation usually. So again, just yeah, good. Okay, so that's the formula you need. I don't think you need these two formulas. Okay, so when the conditions are met, this is our this is our interval. Again, B is the mean of the sample. T critical value, we know how to find that, although degrees of freedom is now n-2. Ooh, that's weird. And then standard error, we just went over that formula. So that's how you're going to create your interval. And again, the standard error formula is on the formula sheet. Okay, calculate a 99% confidence interval for the slope of the population regression line. Okay, so let's try to do this. So okay. So we know our formula is B plus or minus T critical value times the standard error. Okay, so B is the slope. The slope is going to be, the y-intercept is 43.47. It says we're constant. Right below that is the slope, so 2.6181 plus or minus. To find the T critical value, you want to do, put, what is this, 99, so 0.99, so 0.005, so inverse T of 0.995, comma degrees of freedom, which should be 38, because again, it's n-1. So you type that guy into your calculator. So you go inverse T of 0.995, comma 38. We get 2.71. So 2.71 times. The standard error should usually just be given to you. When you have computer output, you don't have to calculate it. If you see the slope, it's the number right next to slope. It's under SE, stands for standard error, so it's the 0.2042. So now you get your calculator out. 2.6181 plus 2.71 times 0.2042. And then we'll do the minus version of that. So it goes from 2.06 to 3.17. See if they did anything differently here. They found those same values. They got the same values we did. That's good. So we did everything right. So a lot of plugging in with this one. Does the confidence interval provide convincing evidence of a linear association between DBH and the Ponderosa primes? So it's a good question. Yes, because all the plausible values, anything within the interval is a plausible value, are different from 0. Therefore, there is a convincing evidence of a linear association between DBH and the height and the population of Ponderosa pines. We think there is a difference there, right? They're convincing. Yeah, T critical value is not the same as T here. They came out carrying. T is, yeah, don't use that for your T critical value there. We don't usually use that. Okay. A t-interval for the slope is a confidence interval. This is what we just made, by the way, used to estimate the slope, B, of a population regression line. So like in the last one, we knew the slope was positive because all the plausible values were positive there. So it definitely wasn't slope of 0. I think this is an example that might be on your paper. So can we predict the price of a Ford F-150 if we know how many miles it has on the odometer? We should be able to, reasonably good. Number of miles driven that was recorded for each of the trucks. So it looks like cars have what we call a depreciating value. In other words, it goes down over time, you use it more, it gets older, it's not worth as much. You look at the scatter plot of the residuals, somewhat scattered there. And I love that they gave you this. So we don't have to type the data in our calculator because they gave us all this information, which is super nice. And they even gave us a graph of the residuals, right? Construct and interpret 90% confidence interval for the slope of the regression line. So looking at that, so state, you want to, 90% confidence interval for beta. The slope of the population regression line related to y equals price is listed for sale on autotrader.com. So t interval for slope is what we're doing. What are the different conditions? So linear, the graph the scatter plot looks linear, but you also want to look at the residuals. Residual plot shows no leftover curve pattern. So if you look at the residual plot right here on the right, it's pretty scattered. There's no curve pattern there, so that's good. So normal, if you look at the residuals graph, they did a histogram of that. There's no strong skewness, roughly symmetric, or at least no outliers there, which is good. Variability of the points around the line residual y equals 0 appears to be about the same at all x values. So at each x value, there's a similar amount of variation. So at each x value, there's some above and some below the line. That's what we need. Random sample of 16 Ford F-150 Super Crew 4x4 trucks on autotrader.com. Of course, we know that we took a random sample of 16, which is less than 10% of all used Ford F-150s. So the do section, we've got to fill in numbers here. They did give us the chart. Where is it? I think they gave it to us. Let's use that. So using the chart, we'd say B is the slope looks to be not the constant 3 at 257. It's negative 0.162 plus or minus. T critical value would be, forgot what the compass level was, 90%. Okay, so 90%, so if you kind of draw that, 0.9 to the 0.05, so inverse T, 0.95, and degrees of freedom is 16 minus 2 is 14. And the number next to the slope is 0.03096. So we get a lower bound of 1.65, upper bound of 1.97. So the slope is positive there. Let's see what they did. Let's see if we got the same values. Oh wait, let's get the calculator. 0.2. Let's see what we did. Oh, I typed it in wrong. So you have to be careful with this. I didn't realize when I hit minus, it was taking the previous term instead of negative 0.160, which I should have used that term. So you get this one and this one. Sorry, it was just a typing error. I typed in, if you type in subtraction, sometimes it takes the previous, do you see how it says answer minus? That's what it did to me. I wasn't paying attention when I was typing. We should get the correct, we did get the correct one. Okay, so glad I double checked that. That was weird. I was like, why have that 1.76 number out there? Because I typed in subtraction and it automatically put in the previous answer that I had on my calculator. So good catch there. So we are 90% confident the interval from blank to blank captures the slope. That's what we're trying to do, of the population regression line relating to y equals price, x equals miles for a used Ford F-150 crew cab truck. In other words, we're 90% confident the average price of a used Ford decreases by about 11 cents to 22 cents per mile driven. That's actually more interesting than what the first one was. The first one's very, formulaic, but actually when you think about what the slope is of this line, it's how fast it's depreciating for each mile that you drive. It didn't take into play how old your car is, which definitely is part of the equation there, but it's, it's a reasonably robust way of looking at this, and I like the way of thinking about that. Every time you drive, this is why, it's tough to make money with Uber, because as you're driving more miles, your car's depreciating every time you drive a mile. So it's tough to make a lot of money that way. Don't always type the data in. Oftentimes in this section, you see we didn't really have to type it in. You might have to, it's definitely possible. You could type it in. So if you did this, and I don't think you're gonna have to do this, you would go to listen spreadsheets. You could call this one miles driven, this one price. You'd put in all these values, 70,583, put them all in. I might do this for a second and then show you what it does. Okay, that took a while to do in my calculator. So let's see if we can do this. So let's go to the calculator screen and go menu 6. It's got to be 6 is confidence intervals. LinReg number 7 says LinReg T intervals. I'm going to try this one. I'm not sure. So XList is definitely miles. YList is price. That's fine. I don't remember if it's 90% or not. Was it 90? Oh, 0.9, sorry. So let me change that. So if I go back up, change the 0.95 to 0.9. Okay, let's see if we get this right answer. So I think that was it. If you look back at your slope was negative 0.162. Lower and upper. Yeah, those are the right answers. So I did the right thing. It was the slope one. I don't know what the other one does. Not sure when you use that. If you want to do a couple extra problems here, you can look at these two. So using the data there, you can see you can grab the slope, negative 1.256. That's our center, that's our mean. Plus or minus 2.101 is the T critical value for 0.975 comma degrees of freedom is 18. And then 0.067 is the number next to slope in the output, says SE above it. And so then you just type into the formula. There's zeros down in the interval there as a negative slope. Does the contour provide convincing evidence of a linear association between? Yes. Because all those values are different than 0, there's convincing evidence of a linear association between the two variables. This, if you really wanted to type in all the data, although no, even here you don't have to type in data. Very rarely you're going to have to type in that data. They're usually going to give you that computer output. I have to check all the conditions there, plug in the numbers, and you get that answer. That's your lesson for today.